I just want to endorse 99% of what Dudley said, and I won't tell you about the 1%. Maybe you can guess as I go through my presentation, but he's provided an excellent introduction to the sector. It's a complex sector, and of course he covered all of the rare earths, and you'll see that as I go on, I'm going to be focusing on only two, which is neodymium and praseodymium for the magnet sector. So that's where our project is particularly enriched, and where I'd like to divert your attention. Richard asked me to come up with a catchy title. That's what I've come up with. I'm not sure whether the rest of the presentation will follow it, but I guess we'll see what happens. Okay, one area that Dudley didn't talk about, but I thought luckily I just have this slide here. The rare earths are there in yellow in the periodic table. The two that I'm going to focus on, as I said, are praseodymium and neodymium. They're these two over here, or NdPr is what we call them. In China, they call them PRND. So, you know, when you're there doing business in China and you're talking NdPr, sometimes it's a bit of a problem when they're saying, is it PRND or NdPr? Well, it's actually one and the same thing. So that's what we'll focus on today. Dudley mentioned as well some of the mineralogy. The main mineral types you can see there in red are the mineral types that the world has historically exploited for rare earths commercially. And on the right there, you will see the percentage or the maximum percentage of rare earths in each of those minerals. And you can see that as you sort of go from the top to the bottom, and as you get down towards the bottom, you'll see some more exotic minerals into which they are either rare earth minerals or minerals in which rare earths substitute into certain elements. And you can see as you go further down, in general terms, the rare earth content decreases, and it generally requires more complex processing to be able to recover those rare earths. And our particular project, the Nolans project, is enriched in, or most of our rare earths are hosted in apatite. So we're one of those projects that has to develop a flow sheet that really the rest of the world hasn't done before. The uppercase and bolded ones are where it shows the mineral type that is dominant in those particular projects. And the smaller ones there, Dubbo, for example, has some bastnasite in it, but it is not the dominant mineral type from which they'll recover rare earths. So a little bit there on mineralogy. A little bit more information on what projects are sort of sitting out there, primarily focused on ASX-listed companies there. But I've also put another couple in there that show other deposits around the world. And the two I want to draw your attention to, the two in red, are of course the two projects, one in China, the giant Bayan-Obo deposit, and Mount Weld, Linus's project, are the only two that are in production in that list. I've also drawn your attention, and you'll notice the ASX listing here for all the different projects. There's the Nolans project for Arafura. Next speaker, of course, is Ian Chalmers for the Dubbo project down here. I've also included a column there that shows the NdPr enrichment of those particular deposits, which is the percentage of the rare earths that's occupied by Nd and Pr. Okay? And the contained NdPr at each of these projects, that's for total resources, not making any statement around viability or ability to recover those rare earths. It's just there as a number. And basically, you can take it that, you know, the larger the number, you know, generally speaking, the potential longer mine life there's going to be, although as an example where it's not quite the case in Ian's company here, in Alkane Resources, only 120,000 tonnes of NdPr, but it's a multi-element project, so you know, the economics are going to be driven by other elements as well as NdPr. For us, most of the economics are driven by NdPr. So each project is a bit different in that particular regard, depending on the enrichment in particular rare earths. It just so happens that at the moment, as Dudley explained earlier, NdPr currently makes up most of the value in the rare earth sector and has the highest growth prospects. So let's talk a little bit about NdPr and permanent magnets. The two photos I have up there are from a recent visit to China We recently visited 3 rare earth permanent magnet companies over there. The left-hand one is just a display that shows all of these little sort of rectangles on here and so on, magnets that are used in the automotive sector, in automobiles, come in all sort of shapes and sizes, but generally pretty small in size. And then on the right there we have an EV traction motor, and a little bit difficult to see. Once you get access to the presentation, you'll see just sort of inward from these little copper strands in here, there are these little rectangles. Each of those is a neodymium ion boron magnet. And so for those of you who are in the copper sector, copper bugs, don't fret. There's plenty of opportunity in copper as well to put into those EV traction motors. And I note that BHP are even beginning to talk it up, which just blows my mind. But anyone here who's interested in copper, you'll be getting a piece of the action as well as the rare earth people in the EV space. Okay, let's talk about some of the applications for permanent magnets. In the black bars, we have the number of tonnes that are in each of the applications down the bottom there. So, as an example, we have 25,000 tonnes of neodymium ion boron magnets going into the automotive sector at the moment. Note that when you come to battery electric and plug-in hybrid vehicles, the numbers that we're talking about, 4,000 tonnes, 3,000 tonnes, is much more subdued. But the light blue show the growth rates. So there's most of the growth that we're seeing in the magnet sector is in the electric vehicle space and also in air conditioning and refrigeration. They're the 2 areas that are going to, we believe, on the basis of information that we've acquired over time, including from people like Dudley, that's where we believe that most of the growth is going to take place. Mind you, have a look at these growth rates over here, starting from 0 here up to 35%. So some of these growth rates are pretty large. It's up above 30%. So is this one here. Some are a little more subdued. In the hard disk space or the optical disk drive space is actually negative growth predicted in magnets. But that's where we believe the compound annual growth rates are going for the different sectors that take rare earth permanent magnets. And that's for 2016 are the current black bars, and the forecast growth is out to 2025. So massive growth in some of these areas that was really endorsed by Dudley's earlier presentation. The average growth over all of those sectors is somewhere around 8 to 10%. So the sorts of growth rates that Dudley was speaking about was even in addition to that. So we're a little more conservative on our growth estimates, but nevertheless, we're in general agreement that there's some massive growth coming in permanent magnets. A little more busy this slide, but on the left here, we see global magnet production. Let's just focus on 2016. Light blue is China. It dominates magnet production. Dark blue is Japan, much more subdued, and there's a little line at the top that says Europe. And we're probably looking at around 110,000 tonnes. I think it's in broad agreement again with what Dudley was talking about. 110,000 tonnes of magnets produced per annum. In the bottom graphic, we see this is now just focusing on China. On the left-hand side, we have again thousands of tonnes. This time we're looking at light blue, China only, domestic use of magnets. And in dark blue, export. So we're looking here at 20% of their production is exported. Sorry, it's 20,000 tonnes is exported. About 80,000 tonnes is for domestic use. This line here is telling us, if we read on the right-hand side here, that from 2013 onwards, the domestic consumption of magnets in China is growing. And we can't see that going backwards anytime soon, and I think again Dudley endorsed those sorts of comments. So that's independent data from what Dudley's been using, I suspect. On the right-hand side, it starts to get a little bit more alarming, as he alluded to earlier. In the green, we have China's domestic production of magnets, again hundreds of thousands of tonnes here. I think from memory this is suggesting around an 8% growth rate, might be up around 10% growth rate. In green is China's domestic production of magnets. Light blue is Japan's. Not looking to grow very rapidly, although some of our guys have just been in Japan in the last week. that might be a little bit underdone. So there might be a little better growth for Japanese magnet manufacturers. In blue, we have China's export, also growing, but not nearly as fast as its domestic consumption, okay? And we have a very small line here again for European, not looking like it's going to grow much at all. The red line here is a back-calculated amount from the amount of NdPr that's produced in China, back-calculated or calculated into tonnes of magnets, recognising that there's around 30% of an neodymium-ion boron magnet is made up of NdPr. It's, in 2016, it's at around 90,000 tonnes. This dotted line is the added tonnes, so between 90,000 and about 130,000, 140,000 tonnes, which is accounted for by illegal production. Now, Dudley explained, and I also endorse, that the Chinese authorities are starting to do a pretty good job of cracking down on illegal production. So we're not expecting that gap to be as large moving forward. We're expecting that to close up. It won't be eliminated completely, but it'll close up substantially. We're also not expecting to see a growth in Chinese sanctioned production, because Chinese sanctioned production is going to have to be essentially built from scratch, we think. We don't think that it's going to be possible for current producers to ramp up capacity anytime soon. They are all very strictly controlled when it comes to environmental compliance. So anything that new that comes along is likely to be slightly more expensive, or perhaps a lot more expensive. And we're not expecting to see that capacity come anytime soon. It may change if China begins to import mineral concentrate or other forms of materials, as Dudley alluded to, rare earth chlorides or carbonate. But even if that were to grow, there is still going to be a very substantial shortfall in the amount of NdPr coming into the market to meet demand for magnets. That's what this graph is telling us. So we are quite certain of our position there on the basis of many visits into China in recent times. What does that mean insofar as NdPr is concerned? The red area here, this is in thousands of tonnes. Remember, the numbers here aren't going to match the previous slide because we're looking at about a third of the tonnes here compared with magnets, recognising there's a third of the tonnes of NdPr going into a magnet. So the red area here is China domestic consumption. The grey area is illegal supply. Our view is that that is going to really tighten up as Chinese authorities become more effective in stamping that out, and environmental compliance is ratcheted up. The blue area in here is rest of world supply, mainly Lynas, although we have factored in a few other producers coming online. This is when we think Nolans will actually hit the market. That accounts for 3,600 tonnes. So to put that into context, Lynas is producing around 5,000 to 5,200 tonnes at the moment of NdPr. So, you know, we're going to be a substantial but not an overwhelming producer of NdPr, looking to come online around 2022, and of course there's a ramp-up period of around 12 months that we've got here. We have a little bit of recycling here in green as well. The black line is the demand for NdPr oxide, and forward from 2016, that line is growing at around 3%. Now, I said earlier that those magnet growth rates were somewhere up around 8 to 10%. That dotted line is 8% growth. Well, you can see that there is already a shortfall in the 3%. Lord only knows how the hell we're going to produce enough product to meet the 8% growths. We'll try. Okay, on its way from misery to happiness. This particular graphic shows in the top here, and if you look at the right-hand axis, this is the price of NdPr from the start of 2015 to today. So you can see there was a drop-off, a substantial drop-off as China removed the tariffs and dismantled the quota system. We also saw that illegal production was flooding the market. That caused prices to drop, as Dudley alluded to earlier. When it came to the early part of 2017, one of the most significant things that happened was that the world's largest producer of rare earths from Bayan-Obo announced a 90% profit decline. So that tells us that at prices of around $40 to $50 a kilo, not even the Chinese producers are going to be sustainable. Now, that's not going to be allowed to happen. If the China 2025 strategy that Dudley said earlier is going to happen, I don't think that they're going to fall short in China in producing the most electric cars in the world. They're not going to fall short because they're unable to procure raw materials. I just don't think that's going to happen. So prices must increase from these sorts of levels if Chinese operators are to be sustainable. We saw prices increase as China began to step up environmental monitoring this year, got up to around $80 a kilo. It's now dropped back. And I think Dudley mentioned some of the reasons for that. Right now, the rare earths world is awaiting some price guidance from China Northern, and we'll see where prices go from there. But one thing that we certainly agreed on whilst we were in China with magnet companies and rare earth separators was that over time, prices will increase. The orange down the bottom are the cumulative value of trades by Australia's listed companies in the rare earth space: Alkane, Arafura, Greenland, Hastings, Lynas, Northern Minerals and Peak Resources for each day. So we took a look at the share price and the number of shares traded at the end of the day. There are some increases over time for different reasons, but of course you can begin to see the value of trades began to increase as the price of NdPr increased. So watch out for further price rises in NdPr because you'll probably find that the value of the companies are going to increase at the same time. Let's move on to Nolans. How much time have I got left? Okay. All right. Mineral resources. I think I mentioned another slide, 56 million tonnes of resources. At Nolans, it's well defined. Left-hand side, little graphic shows the measured, indicated and inferred resources. Measured in red, indicated in yellow. On the right-hand side is the same graphic, except it's now being coloured for just indicated and measured resources. And the red there are what our preferred material types with our particular flow sheet. So we are looking at phosphate-rich material types that are easily processed with our flow sheet. That makes up around 2/3 of measured and indicated resources. It looks like it's more there, but that's a little bit of phantasmagram from one of our geologists. The project configuration: mining, beneficiating and extraction at the Nolans site in the Territory. From there, we produce a mixed rare earth intermediate chloride, which we will send by road to Alice Springs, put on a rail and send to a separation plant elsewhere in the world. At the moment, we have an MOU. It's around 2 years old with a South Korean chemical producer, OCI. So we're looking to build that particular plant in South Korea. From there, we'll be producing 3 products, an NdPr oxide product, which is our main product. We're producing around 3,600 tonnes of that. The capacity of that separation plant is around 7,000 tonnes. So it's much smaller than Lynas's operation. We'll also be producing a byproduct of phosphoric acid, and we drop out cerium early in the process so that it's not separated in a separation plant, which allows us to keep the size of the separation plant down and the capex lower. The flow sheet looks something like this. The big difference between our project and all other projects is that we are employing a phosphoric acid pre-leach in this part of the process here, where we do a lot of acid recycle and produce a phosphoric acid product as well. Once you start getting the rare earth rich stream into the acid bake and downstream in the purification processes, most projects begin to look quite similar. We're currently piloting the flow sheet, as Dudley said. It's necessary to underpin all of your capital and operating cost estimates for DFS. We're currently piloting. We're about halfway through our pilot, so we're staging it. It's not a continuous flow from ore all the way through to separated product. We're running each pilot phase for around 1 to 2 weeks then decommissioning, collecting that data, of course, during piloting to include in our DFS. At the same time, we are going through our environmental process. We have submitted a supplement to our EIS document. Our main EIS document runs to around 2,500 pages. Our supplement runs to around 700 or 800 pages. We've just submitted that with Northern Territory regulators, and we're hopeful to receive final environmental approval for the project in the first half of next year. The project metrics, just briefly, and it's really just to let you know that the project will be producing, its capacity is 14,000 tonnes of total rare earths, which will include 3,600 tonnes of NdPr. One thing that we've really been working on over the years is to try and bring our operating costs down. Our operating costs, as shown in the top part here, is at about $6.23 a kilo of rare earth oxide produced, or $24.38 for each kilo of NdPr produced. Current NdPr oxide price is around $58 a kilo. It got up to around $80. And quickly, just to wrap up, the project, the Nolans project, has been in development now for 10 years. Dudley mentioned that these things just take a long time. We've actually gone through 3 different flow sheets in that period of time, and we've eliminated them on the basis of cost and complexity. So we're now focused on a flow sheet that we believe is less complex and less costly to operate. We've got a high growth and high value permanent magnet focus. We don't think that's going to change anytime soon. The production's projected to coincide with a projected supply gap in the early 2020s. We're located in the Territory. It's a good jurisdiction to do business. We have some strategic support from our Korean partner at OCI. We have a long life, low risk resource that can support mining for more than 30 years. Close to vital transport, energy and water infrastructure. I didn't mention that we're only 130 kilometres away from a 25,000 person town. We think that can support the project. We're only 10 kilometres from the Stuart Highway, and we have a gas pipeline running from the Amadeus Basin up to Darwin, running right through the middle of the project area. So power won't be an issue for the project. We have a very efficient high recovery flow sheet with final piloting in progress. Regulatory approvals are well advanced. We should see environmental approval, which is the key approval, in the first half of next year, and we've got quite low production costs that can remain competitive in cyclical downturns with the addition of our phosphoric acid product, which is about 110,000 tonnes per annum, quite modest. Thanks for your time, and I'm quite happy to take some questions.